2.2 Defining the derivative. The derivative is an expression that calculates the instantaneous rate of change or slope of the tangent line of a function at any given x value. In other words, it gives us the slope of the function at a point. Here we have a function f of x is equal to x squared, just a parabola right here. We're going to learn how to calculate this in a future lesson, but just know the derivative function is equal to 2x. So, with that, f prime of 1 is 2 times 1, which is 2. So if we drew a tangent line of the original function f of x at the point x is equal to 1, like here, the slope of the tangent line here is 2. Similarly, if we find f prime of 2, 2 times 2 is 4 right here. If we draw the slope of the tangent line at x is equal to 2, we'd have a tangent line like this, and the slope of it would be 4. This is what it's saying. So f prime of negative 2, 2 times negative 2 is negative 4. If we draw a tangent line at negative 2 right here, this would just be a slope here of approximately negative 4. So again, the derivative at a point gives you the slope of the original function at that point. 1. Let's say f prime of x is equal to 5 over x minus x. Find f prime of 2 and explain the meaning. So f prime of 2, again, this is the derivative. We can just plug in right here 5 over 2 minus 2, which is just equal to 1/2. For those that forgot, you have to combine like terms. 5 over 2 minus 2 can be rewritten as 4 over 2. So 5 over 2 minus 4 over 2 is 1/2. So this value means the slope of the tangent line of f of x at x is equal to 2 is 1/2. That is the meaning. Again, the derivative tells you the slope of the tangent line of the original function at the point. If f of x represents how many meters you have run and x represents the minutes, describe in full sentences the following. You're going to be tested a lot on the difference between the original function and what the derivative means. So, f of x represents how many meters you've run, x represents the minutes. So this is just the original function. So after you run 8 minutes, I ran 1,500 meters. Again, straightforward. F of x is how many meters you ran. I ran 1,500 meters. And x represents the minutes. I ran 8 minutes. So after 8 minutes, I ran 1,500 meters. This here's the derivative. Again, the derivative is a rate, instantaneous rate. The input here is 3. So at the third minute, I was running at a rate of 161 meters per minute. This is a rate, meters per minute, because this is the derivative, whereas the original function was just the distance, meters. Just some notation you'll see around this course. There's one notation called Lagrange. I honestly don't even know how to pronounce that. Sometimes you'll see the derivative written as f prime of x, like the derivative of f of x, or y prime, the derivative of y. Just like in algebra, sometimes you see, oh, f of x is equal to x plus 1. You can also write it as y is equal to x plus 1. That's the Lagrange notation here. Leibniz notation is when instead of y prime or f prime of x, they'll say you're differentiating y with respect to x. So you can see like f prime of x is equal to 2x, y prime is equal to 2x, dy dx is equal to 2x. Just know these are all the same thing. Just notations, how you can write the derivative. So Another thing here, definition of the derivative. This limit gives an expression that calculates the instantaneous rate of change or slope of the tangent line of f of x at any given x value. Very similar to 2.1. F prime of x, the derivative is equal to the limit as x, sorry, not x, h approaches 0. H approaches 0 of f of x plus h minus f of x over h. Again, you're taking 2 points, and as the distance between them gets closer and closer to 0, that gets you a tangent line, the slope of that tangent line there. So, some practice ones right here now on the next page. Find the derivative using the definition of the derivative, limits. So this is what we just did on the back of the page there. So we have to do f, write down f prime of x. Be sure you write small. We're going to be writing a lot here. Limit as h approaches 0. And we have to do f of x plus h first. So replace all the x's with x plus h. So instead of 2x squared, it's 2 times x plus h squared minus 7 times x plus h minus plus 1. And then we're subtracting f of x. Just this thing here rewritten. 2x squared minus 7x plus 1. All over h. Now here, you have to expand everything out. I'm going to write the f prime of x over here so I have more room. Limit as h approaches 0. Let's expand this whole thing out. So 2 times, if you factor out x plus h squared, that's x squared plus 2xh plus h squared. You can subtract 7x minus 7h plus 1 minus 2x squared plus 7x minus 1 all over h. Again, anytime you're having trouble with how we got something confused, please pause this video and ask your teacher right away or a classmate for clarification. But if you see right here, just from this before we move on, you see how there's a positive 1 right here and a minus 1 right here? We can just cross all those out, right? Just to save some room because there's a lot. You see here there's a minus 7x and a plus 7x. Let's cross that all out right there too. And then if we continue from here, f prime of x, limit as h approaches 0, 2x squared plus 4xh plus 2h squared minus 7h minus 2x squared all over h. And if you notice here, we have a 2x squared here and a minus 2x squared here. These cancel out. And then what you're left with here is we can also, you see we have positive 4xh plus 2h squared minus 7h, and we can factor out an h on top. So 4x plus 2h minus 7 over h. Again, we just distributed the h out of each of these three terms on top. And then the h and the h cancel out. And then you can just plug in the h 0 for h here for direct substitution. So f prime of x is just equal to 4x plus 0 minus 7, or 4x minus 7. Again, there's a lot of algebra and computation here. So again, please, please, please ask your teacher if something is confusing here. We're going to do another example right here. So for question 3, we used f prime of x because they gave us the function f of x. Here, they gave us y, so we can use, honestly, dy dx or y prime. It doesn't matter. I'm just going to say y prime just for short here. So y prime is equal to the limit as h approaches 0. Again, it's f of x plus h minus f of x over h. So let's do the over h first. So the f of x plus h is just replace the x with x plus h squared and subtract f of x, this by itself. So this is going to require some making a common denominator with the fractions. So we kind of cross multiply here. Multiply this fraction here by x squared on the top and bottom. Multiply this fraction here by x plus h squared on the top and bottom. So that gets us, let's see here, an x squared over x squared times x plus h squared minus x plus h squared over x squared times x plus h squared here. The reason we do this now is because we have a common denominator, and now we can just subtract easily on the top of the fractions there. So limit as h approaches 0 of, and one thing I'm going to do here, since we're dividing by h, we can kind of think about this as a multiplying by 1 over h at the end. So I'm not going to write the over h right now. I'm just going to write the x squared minus, I'm going to distribute this out too, x squared plus 2xh plus h squared over x squared times x plus h squared. And again, instead of the divided by h, let's multiply by 1 over h. That's the same thing. And if you see here, what you would get here is, let me just do equal sign over here so I have a little more room. I'm running out of room here. Limit as h approaches 0. So let me just show you up here. X squared minus x squared minus x squared. I'm just showing the top here. On the top of the fraction on the top of the paper here, you see the x squared minus x squared cancels out here. You're left with a negative 2xh minus h squared. And you can also factor out the h here. So that's h times negative 2x minus h. So I'm just going to write that right here. H times negative 2x minus h all over x squared times x plus h squared. That's a squared, sorry, times 1 over h. Again, if you're doing these right, it's going to be an h that cancels out on the top and bottom, like right here. Now you've canceled out the h on the top and bottom, you can just plug in the 0 for the h using direct substitution. And that just gets you negative 2x minus 0, which is just negative 2x, over x squared times x squared, which is x to the 4th. And that simplifies, you can get rid of the x on the top and bottom. That's negative 2 over x cubed right there. And that is your derivative. A very common thing that you're going to be asked on tests and the AP exam. They're going to ask you to find the equation of the line tangent to the curve at a point, which can be represented by this. This is your standard point slope form, but with a derivative, it's just y minus f of a equals f prime of a times x minus a. F prime gives you the derivative of the slope of the slope of the tangent line at the point, and then a comma f of a is your point. So we know h of 5 equals negative 2. So you can think about this as your kind of like your x1, y1. Your input's 5, your output y1 is negative 2. So you can already, right here, in this equation, right, you have a y minus y1, or y minus -2, equals, well, we don't know what f prime of 5 is yet, so leave that blank for now. We don't know what that is. And then it's going to be a x minus x1, x minus 5, right? Your initial point's 5, comma, -2. So we know that of the equation of the tangent line so far. So to find h, they gave us the derivative function here. So to find h prime of 5, just plug in 5. 5 cubed minus 2 over 5. That's just 125 minus 2 over 5, which gives us 123 over 5. So this right here is the equation of our tangent line, just like that. So write an equation of the line tangent to the graph at 2, 7. So again, just have this equation burned into your memory. Y minus y1 is equal to m times x minus x1, where m is just the derivative value, the slope of the tangent line. So you see here, 2 is your x1, and just write that here. x1 is equal to 2, y1 is equal to 7. And then m would just be equal to f prime of 2. So this is the derivative already. F prime of 2 is just what's the graph output when x is equal to 2. When x is equal to 2, you see f prime of 2 is equal to 3 right there, because this is the derivative graph. So if we kind of rewrite the whole line here, the equation of the tangent line here, y minus 7 is equal to 3 times parentheses x minus 2. Just leave your answer like that. Any questions? Ask your teacher, please.